Good morning. Who here has written a macro? Okay. This might turn out, to clarify, a pattern matching based macro. Yeah, none of that def macro stuff. Okay. So this is a little talk about some improvements to the expressiveness of the notation that you use to write those kind of macros. It's not going to change the world, but I think it makes things a little bit more convenient, makes things a little bit more concise, and hopefully readable. So let's start with some background. Macro by example is kind of the thing that kicked this all off. It's a notation for writing syntax transformations, macros, kind of like ordinary pattern matching, but with this nifty ellipsis feature, right? And the effect of ellipses is that if an ellipsis occurs in a pattern, then you match some sequence of things, all of which have to match the preceding pattern. And when you're generating a new term in the template, an ellipsis means do this implicit map over the right pattern variables that show up in the preceding template and produce the right number of things with all the different values that you've collected. Okay, so here's macro by example. We have this beautiful definition of let that says my pattern is, well, I don't care about the keyword position. I take a list of var and RHS binding pairs and then a body at the end. And I transform that into the immediate application of a lambda with the variables and the body applied to all the RHSs. Okay, so if we have let x be 1, y be 2, and x plus y, okay, var, since it's followed by one ellipsis, has depth or rank 1. That means that it has a sequence of terms as its match value, right? And the actual terms are x and y. RHS also has depth 1. It has the match values 1 and 2. Body has depth 0. There are no ellipses after it. So it just has the single term plus xy. Okay. And when we generate the code, there are two variables. So we generate the two terms here, x and y. We put the body, and then we put 1 and 2 for the two expressions. Okay, so everyone's on the same page about ellipses. Ellipses are kind of the magic of macro by example. Okay, so I like to think this started a golden age of parentheses, right? We have this syntax where the structure of the syntax really corresponded to the structure of the data that was used to represent it, right? So groups are generally parenthesized. Is not always true, but it's more true than not. And the syntactic components are actual subtrees in the data representation. And these are kind of saying almost the same thing, but what I mean by this is, like, if you think of something like a binding pair, that is a console that you can point to, right? It's not, oh, these two adjacent things like it might be in Clojure, for example. And macro by example is just fantastic in this world. But around 2007, Racket kicks off this divergence where we add keywords. We have a more keywordy kind of syntax. We start getting non-parenthesized grouping syntaxes. We get optional syntactic elements, and macro by example isn't really so good at handling this. So here's some examples. Racket's function for creating a hash table just takes alternating key and value pairs. Alternating key and value expressions. Here's the syntax for defining a structure type called point. So we have struct point, xy, there's the fields. And then we have these clauses like property, prop custom right, print point, that consists of 3 terms, but that's one logical thing, right? And then we have this other clause that's transparent that affects equality and comparison, and that's one thing. And then there are other variations. There are like 2, I think. And then if we want to extend that, well, there's an optional superstruct that can go in between the name of the struct that we're defining and the field list. Okay, and that might not be there if we're making a built-in struct. So how do you deal with this with syntax case? It looks something like this. If you've got one thing that's optional, then you can make 2 cases. Okay. And to handle the options, you collect them all together and you call a function that just looks through the list and shuffles them off into accumulators and blah. Okay. So this is possible. Doesn't really fit within the macro by example framework though. That's a little bit sad. Okay. So to the rescue, syntax-parse. Okay, so syntax-parse has a couple of extensions to the pattern language that macro by example gives you. You can annotate pattern variables with syntax classes that control whether they accept a particular term. So the name you might constrain to be an identifier only. Okay, or field must be a field description, and there might be a couple different cases like this is just a name, or it's a name with mutability flags or something like that. Okay. We split patterns into single term patterns and head patterns, which might match 0 or more, like a sequence of 0 or more terms that are non-parenthesized. So for example, an optional, sorry, I'll get to optional. So for example, you can say a property clause has the form, well, it's a sequence of the keyword property, property expression, and a property value. Okay? So this is not an S expression in the syntax that you write down, but it's a logical unit, and we have patterns for describing those now. And then disjunctions can result in names that just aren't bound sometimes when you use the macro. So here we say the struct super type is either an actual struct binding, there's something there, or an empty sequence, meaning you just omit that. Okay. One other thing that syntax-parse adds, syntax classes give you the ability to interleave computation with pattern matching. Okay, and you can use this to do context sensitive or other kinds of just predicate checking. You can also use it to compute things that will be useful for producing code later on. So I said we have a struct binding syntax class. We can look it up in the environment, make sure that it's actually bound to a struct name, go and fetch the predicate and accessor so that the macro can use those later on. Okay, so here's computation, here's some predicate checking, and here's some attribute computation. Okay, and so now life is great. We can have our Rackety syntax, and we can use patterns to check it, validate it, take it apart. But I didn't do anything over here. So it's easy to write a macro that takes in the new cool spiffy syntax that has keywords and non-parenthesized grouping and everything, as long as the target still looks like scheme. Okay. And of course, there are ways around this. They just involve extra coding, escaping to Racket. But they don't really fit within the pattern and template language. Okay, so the goal is to draw that horizontal arrow at the top. Okay, so there are 3 new template features that I'd like to introduce to you. One is we want to be able to produce non-parenthesized groups of things. Okay, and of course, if you've only got one group, it's easy to produce a non-parenthesized sequence of things. You just write down the things and you're done, right? But if these occur, for example, under an ellipsis, you need some way of producing those things without adding parentheses around them, basically. Okay, we also want a nice way of dealing with absent variables. And for symmetry's sake, it seems like we ought to have a way of interleaving computation and code generation the same way that we can interleave, computation and kind of predicate checking during pattern matching. So those are the three extensions. And I'm going to give you a quick introduction to the syntax and what they do, and then I'll show you some examples. Okay, so tilde at's just a mnemonic for like unquote splicing, and tilde because I had to choose something that looked visually different from the other things that you would write in patterns and templates. So syntax-parse used tilde for all of its pattern forms. I originally went with question mark because I'd seen someone use that somewhere, but that was taken, so tilde. Okay, so if you have tilde at followed by some subtemplate, the effect is you instantiate the subtemplate, it had better be a list, and then you just splice that into the surrounding context. Okay? Tilde question mark is basically try catch, right? If T1 contains anything that's absent because it was bound in an optional clause or just not one of the disjunction that was taken, then you skip T1 and go to T2. Otherwise, you produce T1. And then finally, you can define template metafunctions. These were inspired by Redx's metafunctions, if any of you have used those. You can define a metafunction that's just a syntax-to-syntax transformer. And then when you're instantiating the template, you instantiate all the subtemplates, and then you apply the metafunction. Okay? So let's look at examples. So here's one. I'm going to do the different features in order. So here's an example where we want to create a hash table that just looks up environments in the current, looks up identifiers in the current environment and creates a hash mapping the symbol version of the identifier to the thing that the identifier is actually bound to, right? To kind of reflect the environment on these names, or reify rather. Okay, so if I say inv hash cons pair ha car cdr, then I should get a hash table mapping cons to cons, pair to pair, pair ha to pair ha. Okay, and remember I showed you before, hash takes alternating key value expressions. So we really want to produce quote cons, the variable reference cons, and so on. And so this is just hash splice, quote the var, and then the actual variable under ellipses. Okay, so if I do this, then I will get a hash table mapping car to the procedure car, cdr to the procedure cdr, and so on. Okay, everyone happy with splicing? Let's see. Here's another example where instead of taking just one thing, I'm taking the keys in the form of keywords and I'm converting them to symbols. And it's essentially the same. I just want to set this up for a refinement later on. Okay, so the core idea is the same, except now I'm matching pairs in the input of keywords and expressions, and I'm producing, well, at runtime, I'm going to call this keyword to symbol procedure on the quoted key and the values. Okay, and so if I say keyword hash of apple, red, orange, orange, banana, yellow, then I get this hash table. Okay. Here's something for dealing with structs that let's say that I want to make some of these properties a little bit more convenient to write. I can create attributes that have parenthesized terms. single terms and then splice them, get rid of the parentheses in the code generation stage. Okay. And this is a nice trick for computing things and not having extra ellipses floating around, right? You just remove the parentheses during code generation. So here's a struct.
So it's code generation flag.
Yes. So if you know the ... trick, that's kind of the only alternative, but that usually requires introducing an extra with syntax and.
That was very painful.
So use Racket, and the pane will turn into a different pane. I mean, so now you have this funny punctuation, right? I think this is better, but I might be biased. Okay, so example. The second thing, let's say that we've got a lock. A lock is just a semaphore containing either 0 or 1. And we have a call with lock procedure that takes a failure argument. Otherwise, if we can't get the lock, we just raise an error. Okay. Yeah, so we try to get the semaphore, we call the procedure, and we release it. Got a default fail. But we want a with lock macro that takes a lock expression, optionally a failure expression, otherwise a body. And we want to, if we were given a failure clause, then we want to actually include the failure keyword argument in the call to call with lock. But otherwise, we don't want to repeat knowledge about what the default is or whatever kind of handling call with lock does. So we just want to eliminate that argument entirely if it's not given to the macro. Okay? So if the optional binding fail is not present when we do the pattern matching, then this whole term will have an absent variable. So the try-catch form will produce nothing instead. Okay, so this is try to produce a sequence, a non-parenthesized sequence of fail and then the handler. Otherwise, if that doesn't work, produce a sequence of nothing at all. Okay, and this combination shows up often enough that you can actually just omit the or produce nothing at all template. And then here are some test cases. Do you want to see the test cases or you believe me? Yeah, okay. So metafunctions. So I showed you keyword hash before where we're converting the keywords to symbols at runtime. Here's a variation that uses a template metafunction to do the conversion at compile time when we're generating the syntax in the macro. Okay, and I keep changing the convention. Today, I kind of like putting tildes in front of metafunctions too. I'm not committing to that. So we have tilde keyword to identifier that just does the datum to syntax stuff. And then we can use this by just saying we've parsed a keyword and value, so we make a hash splice, quote, do the conversion when you generate the template, when you generate the term from the template, from the key. And then you get the same answer, but you do the conversion at compile time. And you can do identifier splicing this way too. So you don't have to introduce a with syntax for that. I'm going to skip this example and show you some curious things. So here's, I think, maybe a useful utility template metafunction. Begin 0 just throws away everything except the first argument. Okay, and you can use this for ellipses when you need a pattern variable there to drive the ellipsis, but you don't actually want the result. Okay, so here's something that takes a bunch of identifiers and that defines them all to be false. I mean, you can do the same thing at runtime by producing like begin, quote the name, and false, or you can eliminate that at compile time. Right? So the x here is driving the ellipsis, but the only term that actually gets produced is false. Okay, and here's an example that combines, so let's say idmask takes things which may or may not be identifiers and produces a quoted list of 1 where there is an identifier and 0 where there wasn't. Okay, and we do this. So if it's not an identifier, then x is not bound. So we use try catch and begin 0 together to have the x driving the ellipsis, but we only produce the term 1 if there was an identifier bound. Otherwise, we produce 0. So, yeah, given idmask of A, B, 3, 4, E, you know, on, off, on. Yeah.
Did you inverted the nesting of the try catch and begin 0?
If I inverted the nesting, then it would be like it would be an and map or map kind of thing. Yeah, so to get this result, this needs to be innermost. Yep. Okay, and then we can do compile time fold. So here's fold as a template metafunction, and then here's my let, which is just folding let over the binding lists and the body. Okay, so I hope at the very least you're like, oh, that's cute. Okay. So here's a grammar that shows you exactly what's going on. So like I said, we split patterns into single term patterns and head patterns back for syntax-parse. Now we're just doing the same thing for templates. Turns out this was already in the scheme reports. They just called head patterns, I think, template elements before. But the idea is that you can have as many ellipses after a template as you like. And this is just generalizing that to more things over here. And the implementation is pretty straightforward. For a pattern variable, you produce the variable's value. For literal, you produce the literal syntax constant. This has no effect. This is ellipsis escaping. No effect on template generation. This is append. This is try catch. It really is almost just exception handling. This, you generate that and then call the metafunction. These are also try catch, and this is just check it's a list and splice it. And you can only use that in a context where you're going to append it, so there's no append error if you do the list check. Okay. I pretty much said all of this. So a head template generates a list of terms. I'm going to skip the difference between Racket's notion of what a syntax object is and Scheme's notion of what a syntax object is, but that gets tied up in the implementation too, but it's pretty straightforward. So there's like a little optimization for saving space and time where it's kind of more convenient, instead of constructing a list and then turning it into a syntax object using a wrapper around datum to syntax. If you start with a constant syntax term and then say where to replace things inside of that, that turns out to be a little bit of a space savings and a little bit more of a time savings. Not a lot, at least compared to the whole process of building Racket, but noticeable. Okay. I think, well, I have two more ideas. it would be nice to have an index thing. People use generate temporaries both for, I need an arbitrary list of identifiers, and also I need fresh identifiers. But hygiene already takes care of the second part for you. So this is a proposal for a template form that does the arbitrarily many part of that without adding additional freshness. And this is a sketch of how you would use it, for example. So you want to do set values. So you generate your temporaries to store the right-hand sides, and then you do all the set bangs at once. Okay. And then a lot of this is motivated by getting things to work with ellipses. So maybe we should just teach unquote about ellipses and have we should teach unsyntax, the partner to quasi-syntax, about ellipses and pattern variables that drive ellipses, and have it do something more intelligent there. And then we don't really need metafunctions as much anymore, or at the very least we can say, using one of these unsyntax things is just like applying an anonymous metafunction. Okay, so thanks, and feedback. What do you think's good? What else would you like? And we'll let you know if you have time to tell me.
Yep. We got 1 minute left before. And Kyle, can you get ready to entertain questions? So, anyone who's written too many syntax rules macros knows that you can do a lot of things in the pattern template style, but then eventually you realize that this was a very bad idea, and it's much nicer to write a scheme or Racket program to do that instead. And some of the examples you showed seem like they're leaning more back in that, oh look, we can use string constants to mark our different cases in syntax rules direction. Can you say more about where the balance is between doing too much cleverness in the pattern language versus just writing some programs that we all know how to read?
Yes, I think that the balance is right where I stopped and no further. I think that you have a point, and I think that the previous state of the art was a little bit too little support, and I've had arguments with various people about whether it's useful to add more variants of, like, maybe you want a 3 version that's instead of try catch you want if then else, but then in that case maybe you want let also, and yeah, we don't want the template language to have a whole general purpose programming language embedded in it, because we've got one of those and we like it. So, but I think this was probably more helpful than not. I'm inclined to think that.
As someone who has written a lot of the other style, some of those syntactic conveniences would be nice to have.
Yeah, I mean, I've written all
2 against 1.
I've written all of those
There you
things
go.
a million times with the like, oh, well, look, we can add an extra set of ellipses, and then I don't have to get out of pattern. Then I don't have to write map here. And I have done that many times.
Then I'll have to change syntax rules to syntax case, and I'll have to add the friends of the syntax argument. And, yeah. Okay.
All right. Thank you, Ryan.